Imagine trying to shoot a laser, like 36,000 kilometers from space, through our messy atmosphere, and hit a target precisely enough to send data at a gigabit per second.
Yeah, that's been the dream, hasn't it, for, well, decades.
Exactly. But it seems like someone's finally cracked it. Welcome to the deep dive. Today we're digging into a recent Chinese satellite mission that did just that.
It's pretty remarkable stuff.
Yeah. So our plan is to unpack what they did, see how it compares to things like Starlink, and really get into the science behind it. So you walk away actually understanding this huge leap.
And it's more than just a tech demo. These kinds of advances, they really can change global connectivity. Big implications for how we all get information.
Okay, let's jump right in then. The core achievement. A Chinese satellite transmitting data at 1 gigabit per second. Pretty fast.
Very fast for space links, yeah.
But the mind-bending part. It did this from 36,000 kilometers up. That's geosynchronous orbit, right?
That's right, GEO. So the satellite stays roughly over the same spot on Earth. Constant coverage potential.
And get this, the laser they used, just 2 watts. I mean, that's less power than some nightlights. It's almost unbelievable.
It really puts things into perspective. And, that's where the comparison with something like Starlink gets really interesting.
Okay, so how does it stack up?
Well, Starlink satellites, they orbit much, much lower, like around 550 kilometers, low Earth orbit.
Right, ELEO.
And their speeds are usually, maybe 10, sometimes a few hundred megabits per second, which is good.
But this Chinese satellite is what, 65 times further away?
Exactly, 65 times the distance, and achieving speeds that, they far surpass Starlink's typical rates. It's not just faster, it's faster over an immense distance. That's the kicker.
Wow, okay. So sending a laser beam that far, keeping it focused through all the atmospheric turbulence, that just sounds incredibly difficult. Like you said, aiming a hose at a tiny target miles away. How do they even maintain the signal clarity for those speeds?
Yeah, that is the million-dollar question, or maybe the billion-dollar question here.
Yeah.
And they seem to have a really elegant solution. It's something they call AOMDR synergy.
AOMDR. Okay, break that down.
Right. So AO is adaptive optics. Think of it like sophisticated, super fast adjusting glasses for the laser beam.
Ah, okay.
It actively corrects for the blurring and shimmering caused by the atmosphere. Twists and turns in the air distort the light, and AO compensates for that in real time.
Okay, so that keeps the beam sharp. What about the MDR part?
MDR is mode diversity reception. So instead of just sending the laser signal in one mode, or let's say one simple beam shape, they essentially transmit the data across several different modes or light patterns simultaneously. The atmosphere might mess up one mode, but another might get through clearer at that exact instant.
I see. So it's like having multiple paths for the data.
Kind of, yeah. The receiver on the ground collects all these modes and can basically piece together the best parts of the signal, even if some parts are momentarily disrupted. It makes the whole link much more robust against that atmospheric turbulence.
So it's that combination, the adaptive optics, cleaning the beam, and the mode diversity giving it resilience. That's how they get the speed and clarity.
Precisely. It's that synergy, that 1-2 punch, that seems to be the real breakthrough here, the aha moment, like you said.
Incredible. And, this kind of innovation, it doesn't just happen, and we should probably mention the people behind it. Professor Wu Jian from Peking University and Lu Chao from the Chinese Academy of Sciences were key figures, right?
Absolutely. Important to credit the researchers driving this and thinking bigger picture. This isn't just, faster internet from space.
Right. What are the broader implications?
Well, think about the efficiency. A 2-watt laser doing this job from 36,000 kilometers. That suggests future systems could need way less power.
Which could mean smaller satellites, cheaper launches.
Potentially, yes. Smaller, cheaper equipment, both in space and maybe on the ground.
Yeah.
It could sort of democratize access to these high-bandwidth GEO links.
Yeah.
Make them much more affordable than traditional microwave systems.
So you could connect really remote places, like for disaster relief or scientific research.
Exactly. Imagine real-time video from a disaster zone with no ground infrastructure, or streaming huge data sets from, say, a space telescope that previously took ages or cost a fortune to downlink. It opens up possibilities.
So this really does push the boundaries for space-based internet, potentially redefining how data moves globally. Why should you listening care about this right now?
Well, you should care, because this looks like a really significant step towards truly global high-speed internet coverage, especially for fixed locations that GEO satellites serve best. It points towards a future where maybe even the most isolated communities could get reliable, fast connections. And that could fundamentally change things like economic development, education, healthcare access, basically information access for potentially billions of people.
Okay, so just to quickly recap the key points, we've got this amazing 1 gigabit per second transmission from way out in geosynchronous orbit,
36,000 kilometers.
using a tiny amount of power, just 2 watts. It blows past the typical speeds from lower orbit systems like Starlink, and the magic behind it is this clever AO-MDR combo tackling atmospheric interference.
That's the essence of it, a major leap.
Definitely changes the game.
And maybe a final thought to leave you with. As this kind of technology develops, how might it really reshape our global access to information? And thinking beyond just access. What new challenges or maybe opportunities arise when multiple nations can deploy this kind of high-speed, space-based internet infrastructure?
That's a really interesting question to ponder. Lots to think about there. Well, thank you for joining us on this deep dive.